fractions class, we are going to start with these notes here. Okay, so for any real number a, the square root of a squared is actually the absolute value of a. So what we're talking about is, so while we knew that we could do some stuff like these, we cancel each other out and we're left with just a, we are now talking about how it's really the absolute value, meaning that it's going to be the positive value of that, because absolute value is always a positive number because it's the distance from 0. So go ahead and get this in your notes, hit pause, and we're going to move on. Alright, so what I'm saying here is, if I'm looking at a, so go ahead and get these examples in your notes, hit pause, and I'll move on. Okay, so if I'm looking at example a, the square root of 15 squared, normally we would just say, oh, that's 15. And I would say that's correct, but first you're going to find the absolute value of 15 and then do it. So it would look like this. Because if we look at b, well, what happens if we undo those? Well, we're left with negative 12, but that doesn't make sense because anything, a negative times a negative is always a positive, and that's what that says. Negative 12 times negative 12 is a positive 144. So then we will just take the absolute value of negative 12 and make it equal to, and then that would be 12. So we still get to the same number. Same is true for C. It's going to be the absolute value of y. So in your homework, this right here, you may be asked to do a question and you're going to type the word y, type the letter y and say, why is my answer wrong? It's because it's looking for absolute value bars. That would be like number 17 and 18, I think it is. If you have questions, you can always ask me in class or Miss Wadley. And then D, again, I just wanted to show that if we do that negative y squared really means the square root of negative y times negative y, which is going to be a positive y. So it's the absolute value of y. So here's the big thing. If our n, so if we're looking right here, if our n is a positive integer, an even positive integer, then we're going to have the absolute value of a. There we go. I lost my little pen. If my n is odd and positive, then it's just going to be a. It could be positive, it could be negative. We're not going to worry about the absolute value. So really, you use the absolute value when n is even. It's not necessary when n is odd. Okay, so not necessary when n is odd. So make sure you get that in your notes. Hit pause. So if we're looking at this, my n is even, so then my answer would be the absolute value of negative 5, which is 5. But here, my n is odd, so I'm just going to end up with negative 5 because n is odd. Now this one, C, we have a negative out front, and remember from yesterday, that's like saying negative 1 times all of this. So we are going to have an even, so we're going to have the absolute value of negative 3, and the absolute value of negative 3 is a positive 3, and then we're going to multiply that by that negative 1 that is out front. So that's what this says here. So negative 1, so the absolute value of negative 3 is a positive 3, and negative 1 times positive 3 is a negative 3. So this one is a little bit trickier. So this has the negative, so we know we're going to do negative 1 times, but I'm going to go ahead and write this out. So I'm going to say it's the fourth root of m times m times m times m. So 1, 2, 3, 4, 5, 6, 7. Is that 8? Nope, that's 7. So remember, these are all being multiplied, right? So I need to look for groups of 4, because this tells me that I need to look for groups of 4. So I have one group here. I have one group here. So I'm going to pull 1 out. So I have an m. So I have negative 1 times m times m, right? Because there's one here, one group of m's, one group of m's. So then we end up with negative 1 times m, which is negative m squared. That is one way to think about it. Another way, those of my students that had me last semester may have seen this. I like to rewrite these as fractions, fractional rational exponents, because I know that I could rewrite it as -1 times m. This could be 8/4. We learned this when we were doing sum and difference of cubes of powers higher than 3. Remember I said if we're doing a difference of squares and it's divisible by 2, it's because we're going to divide it by 2. So this is where that's going to come into play, and I end up with -1 times m squared, because 8 divided by 4 is 2, so we get -m squared. So my n is even, and then I got to multiply that -m, -1 by m squared. So that is how you can do it. If you have any questions, please ask in class. Alright, so go ahead and do these two here. Again, I would rewrite this as x to the 24/3, but you also could write out 24 x's and pull out groups of 3. This is doing the same thing, isn't it? Right? It's doing the same thing. So we're going to, and then my n is odd, so it's going to be whatever this is. So x to the 8th. And then e, this is even. So I'm going to end up with, so this is another way to write it. So I'm going to have 3 groups within here, right? 3 groups of 6. And we're going to end up with the absolute value of y cubed. So you may get something like this on your homework, number 17 in particular. I think it's 17. So make sure you have those absolute values. That's what it's looking for in the homework. If you told me that this was equal to y cubed, I would accept that as your answer. I'm just helping you get your homework right. All right, and that was it for the notes today. I hope you have a great day, and I'll see you all tomorrow. And yeah.